On behalf of Father Maritime Intelligence, I would like to welcome...
The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. My name is Catherine Austin, and on behalf of Father Maritime Intelligence, I would like to welcome you to Ship Efficiency, the Fuels of Tomorrow webinar. During this webinar, our panel of industry experts will be presenting on the alternatives to bunker fuel oil in the maritime industry. This webinar will examine the alternative fuel options for the future, touching upon the so-called fuel trilemma and the next generation of marine fuels. We will also explore the industry's uptake of LNG as a marine fuel and progressions in the global infrastructure for LNG bunkering. Our panelists will also tackle the issue of safety and cost-efficient loading of LNG bunkers. And finally, this webinar will also host a discussion around the Sustainable Marine Biofuels program that was launched by Wärtsilä, Boskalis and GoodFuels Marine in late 2015. To help prosper and catalyze dialogue around the fuels of tomorrow, today's webinar panel will host the following expert speakers. Christos Chryssakis, the Group Leader of Propulsion and Fuels at DNVGL. Morten Christophersen, the CEO at Connect LNG. And Dirk, the CEO at GoodFuels. Before we commence with the first speaker, I would quickly like to address a few house rules for this webinar. This webinar is scheduled to run for 1 hour. Upon the final speaker completing their presentation, there will be a question and answer session for approximately 10 minutes. Throughout the webinar, we would like to invite all attendees to pose their questions to the panel. However, in order to do this, please post your question into the webinar chat tool. I will then put your questions to the panelists during the Q&A session. If you would like to address a specific speaker, please mention their name at the start of your question in the chat toolbox. Please note that due to the limited time that we have, we may not be able to read out all of your questions. However, if your question wasn't addressed, or if you'd like to get in contact with any of our speakers, we can coordinate that through the Father Maritime Intelligence team, as I'm sure the speakers will be happy to answer anything offline. With those rules stated, I'd now like to hand over to our first speaker, Christos Chryssakis, the Group Leader of Propulsion and Fuels at DNVGL. Over to you, Christos.
Thank you. Can you hear me well and see my screen?
Yes, we can hear you and see your screen. Thanks.
Okay, thank you very much. I'm going to talk about what we call the fuel trilemma, or some thoughts on next generation of marine fuels. This is also, this is the result of a position paper we published a few months ago, and this is available as a handout, as a PDF, together with another position paper we published about 2 years ago now on alternative fuels. So, what we mean with the fuel trilemma. When we are thinking about the future fuels for shipping, there are a number of things to consider. One is related to fuel mix diversification that we start seeing in other industries, and we have some signs that this might happen in shipping as well. Then we have fuel prices. We were used to saying that fuel prices or oil prices are increasing or are high. Now we see that we actually have a fuel price volatility. It's very predicting future fuel prices is very uncertain, and this introduces a big uncertainty into these decisions. Then, of course, we have emission regulations through the IMO, the emission control areas, or some national regulations or local regulations, like the European Union ones, or the NOx standard that will be introduced in the US emission control area next year. And this is going to affect the fuel choice. And of course, we have climate change concerns. This, even though shipping is not part of the agreement that was taken in Paris in December, still there is a push for reducing greenhouse gases. And of course, any new fuel will have to be available, and one of the most important parameters is the cost of the fuel, the cost of equipment, and the cost of building the infrastructure for using the fuels. And last but not least, especially for us at the DNVGL, is safety. Introducing any new fuel will have to be done in a safe way. So, and maybe there are even more things to think about when trying to decide on future fuels. So we're trying to group all these items in three groups. So we have what we call affordability, and this is related to cost. We have sustainability, and this is related to the environmental performance of the fuels, and then we have safety. And sometimes we take safety for granted, but especially for new fuels, we need to consider that. So I'm going to go quickly through these three areas, and then I'm going to show you some examples that we worked on. Affordability is probably the cost is the single most important parameter when considering new fuels or any new technology, actually. As I said, there is a lot of uncertainty regarding oil and gas prices, and this affects new fuels as well. And this is one of the big challenges for any emerging fuel or any emerging technology. It has to compete with well-established conventional fuels. So we have a very good infrastructure for getting oil out of the ground. Now, if we want to produce biofuels, for example, we have to make sure we make it in a competitive way. And of course, there's a lot of discussion on subsidize and other ways that could make alternative fuels more attractive. But this is a big challenge. On the other hand, when we're thinking of the cost of using conventional fuels, it's not just the fuel price that we have to pay if we use, let's say, if we use HFO, but we might have to think about exhaust gas cleaning equipment, scrubbers, NOx reduction technologies. So these are things that are also coming into the equation. Then we have the sustainability of the fuel, and we could include availability here, especially for biofuels. Here we need to think about the environmental footprint through a life cycle assessment of the fuels. We need to understand what is the baseline, because when we compare against HFO, for example, this is not a fair comparison. We should compare against HFO plus scrubbers or against desulfurization of the fuel, because this is alternative fuels are first going to be used in areas where in emission control areas where we have regulations that will help them. And then, especially when we talk about biofuels, there is a big question mark. This is how much fuel can we produce in a sustainable way and without competing with food production, for example. Here on the lower right, I have a small diagram. You can see what is the biomass potential expressed in energy units for different feedstocks. So we have energy crops, we have forestry, we have waste, agricultural residues, and forestry residues. And excuse me. These bars show the uncertainty. So, for example, from energy crops, this is a review of many technical papers that have been published on this issue, and these are taking the minimum and the maximum limits. So you see that there is big uncertainty over how much fuel we can produce in a sustainable way. The good news is that here we can see what is the current human utilization of biomass, and we see that there is about 1/3 of that is biomass discarded or destroyed. So there is actually very good potential for producing fuels in a sustainable way. And finally, we should not forget safety and reliability. When we are talking about new fuels, new alternative fuels, what we would like to do at the DNVGL is to look at the fuel properties. Excuse me. look at the fuel properties, do risk mapping. We use a barrier analysis for that and a safety assessment, and for that we use this bow tie methodology that you can see here. We have an unwanted event. That's an event you want to avoid, and you have threats that could lead to that event. And then we need to develop barrier functions so that this event does not happen. And on the other side, if that happens, then we need to develop barrier functions to make sure that we avoid the consequences. In order to do that in the best way possible, here in this graph you can see our approach for introducing this safety assessment into the design process. So you start by defining, excuse me, but this is very sensitive. You start by defining the mission of the vessel, then the function, the main characteristics of the vessel, the main form, the hull lines, space and weight balance, and then we make a first estimate on performance of the vessel, and then at this point we should introduce the safety assessment for new fuels, and then we should look at the economics, and then probably we need to repeat this process to make sure that we have a good combination of performance, safety and economics. So this is how we think it should be done for new vessels using new fuels. So now I'm going to very quickly talk to you about some case studies. In this publication we have, we looked at LNG, we looked at shore-based electricity, we looked at a number of biofuels, not the most common ones. We just used some methanol and pyrolysis oil as examples, and we looked at hydrogen. Now, because we have a very short time, I will just talk about LNG and shore-based electricity, and I will just give you some general comments on the rest. So LNG is a fuel that we see that it starts developing quite well lately. We had the right conditions for developing that as a fuel. This started in Norway with cost incentives through the Norwegian NOx fund, and it was also a very good technical solution for addressing NOx and SOx restrictions. So this was a good solution for the emission control areas, and we also had the fact that in North America we had very cheap gas due to the shale gas technology. So it's a combination of factors that helped LNG reach a stage where it can grow now. There are still some issues related especially to the greenhouse or to the global warming potential of the fuel. We could have some methane leakage during production, but also from the engines. And this is something that we need to make sure that we understand well and that we need to address. Currently, if you look at the graph on at the bottom of the page, we see the life cycle greenhouse gas emissions of HFO, low sulfur distillate fuel or HFO with scrubber, compared with LNG, average LNG emissions, and LNG if we manage to take care of all the methane leakage. So there is potential for reducing greenhouse gas emissions by approximately 25%. And of course SOx emissions go to zero, and NOx can also be reduced quite a bit depending on engine technology. I want to show you a graph showing the development of the LNG fleet. You can see these are confirmed orders, so you can see that there is significant growth in the last few years, and we think this is going to continue. I want to say a few words about electricity, because we're going to see electricity as a form of propulsion or for some ships, for some small ships. In Norway we have a small ferry running on batteries now, but we're also going to see cold ironing used in ports more and more. And of course you can think about the emissions for producing electricity in different countries. This is what the graph on the right is showing, and what is the cost of that. So we need to make sure that this is an attractive option for vessels. And of course, we can also see batteries on board ships in the form of hybrid propulsion systems. DNVGL has battery rules, so batteries can safely be used on board vessels. As I said in the position paper, we looked at a number of other alternatives. We looked at a couple of biofuels. We looked at their environmental footprint and at their cost, and we did the same for hydrogen. In general, what I can say is that all these options, the environmental performance depends very much on how you produce the fuel, what kind of energy you use, what kind of feedstock you use, what processes you use, so biofuels can reduce our greenhouse gas emissions quite a bit if we produce them in a good way, or they could just reduce it marginally if they're not produced in a good way. So there's a wide range of fuels there. But the main barriers right now are the cost of the fuels, and especially for hydrogen, it's safety issues that also translate into cost later. Very quickly, I want to show a slide from a study we completed in November last year, comparing a number of fuels. Here we compared LNG, LPG, methanol, and ultra-low sulfur fuel oil. We looked at the investment required, and we used two price scenarios, and we looked at the return on investment and payback period, and we found that LNG is a promising fuel. Given the right prices, especially in the US, it can be a very good solution. On the vessel we used here as an example, we had a NECA exposure of 30%, but we also found that LPG can be a very promising solution. So this is quite interesting. Methanol, at least from a technical point of view, could also be very good, but right now it seems that it's a little bit more expensive than what would be convenient for using it. Then, as I said, we need to look at the environmental footprint of different fuels. This is an example from a previous study we did that was published 2 years ago, looking at life cycle greenhouse gas emissions. And with blue color, you see the contribution of the production phase of the fuel, and with green, the utilization phase. And so here you have conventional fuels, and on the right side you have some biofuels, and you see that depending on how you produce your biofuel, you can have a very wide range of emissions. So this is very important to keep in mind. Finally, my last comment is that whatever new fuel we use, we have to make sure it's available. On this table, we have the consumption, the global consumption of different fuels for all purposes, not just for shipping. And you see that oil is number one. This is after coal, actually. Oil is number one. Then natural gas is number two, but LNG is only about 10% of the total natural gas use, and everything else is pretty small. So in order for any alternative fuel to compete with conventional fuels, we really need to increase the production capacity and make sure that these fuels will be available where they're needed. And for this reason, we think that alternative fuels will first be used locally for local shipping, where small volumes are required and where there is security of supply. And then once a new technology is proven, then it might be used in other geographical areas, and this is what is happening with LNG now. It started in Norway, now it's moving to North America, and we think it might become a global fuel in a few years. So availability is very, very important. So to conclude, it's very hard to say what is going to be the fuel of the future. It's a very complex decision, and it's a case-by-case decision based on the ship type and operating profile, on the emissions regulations in the geographical area where the ship is operating, and in the future, things like climate change concerns will become more important. Of course, fuel availability and cost will always be very important parameters. So I would like to thank you, and I will be very happy to take any questions later or after the webinar. Thank you very much.
Great, thank you, Christos. And that was very interesting, especially around the availability of future fuels and sort of the first future fuels may be used for local shipping and then may spread geographically and even globally. I think that was the most interesting perspectives that we've gained from DMVGL there. Like Christos mentioned, if you have any questions for him, then please post them into the webinar chat tool, and we will pose them to Christos within the Q&A section. I would now like to hand over to our second speaker, Morten Christophersen, CEO at Connect LNG. Over to you, Morten.
Thank you so much. All right. So thank you so much for inviting me to share with you what we are working on and my insight into the LNG industry. My name is Morten Christophersen, and I'm the co-founder and CEO of Connect LNG. So Connect LNG is a Norwegian maritime technology and engineering firm with head office in Oslo, Norway, as well as offices in Singapore and Shanghai. Our company consists of naval architects, maritime engineers, and process engineers with a background from shipping as well as onshore industries. And everything we do is based on a long Norwegian track record within maritime technology and especially LNG. We work for clients both in the downstream as well as the offshore industry with an emphasis on hydrodynamics, floating structures, and cryogenic equipment. One of our key focus areas is our patent-pending turnkey transfer system for ship-to-shore transfer of cryogenic liquids, especially LNG. And this will be my primary topic for the rest of my presentation to you today. Our company was founded on a belief that cleaner and cheaper energy should be accessible for everyone. We truly believe that more use of natural gas as a primary source of energy is a sustainable way towards a cleaner future. And throughout my presentation, I will share with you how we are contributing to making this transition possible. So why LNG? For the past 30 years, the world has seen a continuous growth of trading of natural gas in its liquid form as LNG. And LNG has primarily been used as a method of transporting natural gas in larger quantities between continents. But as we've seen lately, we have seen LNG be used as a product for other industries, such as fuel for transport sector or feedstock in production, and for power generation in remote areas not connected to the gas grid, like for instance in Scandinavia. Both end users and governments around the globe is moving their attention towards LNG as a source of energy, not only for transportation. And the main reason for this is, first of all, LNG is a relatively cheap source of energy. And second of all, there are some huge environmental benefits by converting from heavy fuel oil and diesel to LNG. For instance, from only one typical small-scale LNG terminal, this represents almost the yearly CO2 reduction from 32,000 cars. And to get the same level of CO2 reduction, one needs actually to build 130 soccer fields of solar panels. And not to mention the NOx, sulfur, and particle emissions we also reduce by converting to LNG. So,
Morten, excuse me, sorry,
yeah.
it's Catherine. Might you be able to just minimize your webinar screen tool just because it's blocking part of your presentation?
Oh, really?
Yes.
Okay, how do I do that? Like this?
Perfect. Thank you so much. Thank you.
All right. So yeah, I mean, clearly there is a cost incentive for end users to switch to natural gas, and in addition to the environmental benefits, this is exactly why governments around the globe is keen on pushing this forward. And the result has been considerable worldwide investments in LNG the past years. and it is projected a strong demand also in the long term. Even in the short run, and despite the low oil prices, LNG trading and infrastructure is actually considered as, quote, one of the few bright spots in the oil and gas and shipping markets by traders and experts. The order book for vessels running on LNG as fuel has also increased, and the fleet will almost double in just a few years. But this market will, in the short run, primarily be driven by IMO regulations and the governmental push, and ship owners taking a strategic approach until oil prices pick up. So the main increase in LNG trading is mainly driven by the need for supplying natural gas grids and for power generation, primarily in Asian countries. And this will probably be the main role of LNG in the future as well. However, the large potential lies in downstream distribution of natural gas. China is planning to double its domestic gas consumption in the energy mix the next years. EU is incentivizing the shipping industry to convert to LNG as fuel. And we see more and more export licenses being issued for export of US shale gas, making end users in especially Latin American countries and the Caribbean turning their attention towards LNG. However, the main bottleneck for the industry, as we see it, is that the infrastructure for downstream distribution and use of LNG is not yet in place. We are actually approached nearly every week by clients all around the globe which are looking for good solutions to their infrastructure challenges. And now I want to explain briefly how what they are telling us. So let's take a look at the value chain. On the top here, you see the traditional large-scale value chain, which is well established all around the globe. And on the bottom, you see the mid to downstream distribution of LNG to end users, the more regional distribution in smaller scale. We have been approached by large-scale LNG export facilities and large import facilities which want to serve the downstream LNG market because they see the huge potential which lies there. However, their main problem is that their terminals is designed to serve larger vessels where they need considerable modifications to be able to support small vessels. In addition, they do not want to make any adjustments to their terminal, which may interrupt with their ordinary business. And on the end user side, clients are telling us that even though they want to convert to natural gas due to the low energy prices, they say that the small volumes doesn't justify the infrastructure investments which are needed. And the main reason for this is that the LNG terminal capex doesn't scale that very well with the size of the terminal. On the left side here, you see the cost components of a typical large-scale terminal. And on the right side, the cost for a typical small-scale terminal. And what we see is that the jetty capex, in many cases, represent almost half of the total terminal costs for a small-scale terminal, which in turn makes the payback time too long to justify the investments. So even though the terminal is smaller, one still needs a pretty large jetty or dredge large areas of the seabed, which is very costly and time-consuming. In addition, there is often difficult to get approvals to build and dredge in the shoreline. And what we are doing at Connect LNG is removing the need of building jetties and dredge the seabed to reduce one of the largest cost drivers in LNG terminals. And now I'm briefly going to show you how we do this. I'm going to show you a short video. Unfortunately, my audio doesn't work today, but you will also find the video on our web page, connectlng.com. So this shows the traditional solutions to build jetties. And often in a combination of dredging. So this is our transfer system. It's essentially a floating jetty. So we use a mooring system to moor the vessel, a traditional multi-buoy mooring system. And as you see here, the transfer system or platform is stationed close to shore when it's not in use. And we use a tug to push the platform towards the vessel. All right, so that was just a sneak peek to our system. Okay, so the UTS consists of a traditional multi-buoy mooring system to station keep the vessel. Consists of a unique platform connection unit, which is capable of connecting to a wide range of different vessels without any need for modifications. Consists of cryogenic floating hoses designed for offshore use in very harsh environments. And also idle mooring and hull storage to be able to remove the system from the harbor basin in between transfer operations. We are providing a turnkey system consisting of traditional proven technologies. Efficient and safe marine operations are very crucial for ship owners. Therefore, we have based the whole operation on traditional harbor operation as it is done in harbors today. We are taking great pride in providing a safe and easy handling. Therefore, the whole operation is developed in close collaboration with the terminal operators. And I must say that it has been very important to have the people who are actually performing the operation on board early in the design phase to include their viewpoints in the design and to be able to provide an efficient and safe operation for the terminal crew. So our patent pending system significantly reduced the terminal capex and it can be deployed quickly. It is flexible and scalable to be able to take into account an uncertain future with minimal future terminal modifications required. The system is universal, which means that it's able to connect to any vessel without any ship modification needed. Since it's floating, we reduce the intervention with the surrounding marine environment, which therefore reduces the regulatory hurdles, which often is difficult when you want to construct huge structures in the shoreline. It's able to be relocated or resold later if the market should change over time, or implemented as an intermediate transfer solution. And last but not least, the system decreases the collision risk, which ship captains are often concerned about when berthing in harsh weather. And it provides an immediate disconnection and separation between the terminal and the vessel in case of an emergency. Currently, we have more than 24 specific projects in our pipeline for the system, ranging from reloading project, small-scale import for power generation, and even some for bunkering as well. We have already successfully delivered a basic design for a large European LNG terminal owner This customer is primarily importing large quantities of LNG today, but they wanted to expand their business into supplying new downstream markets. And our challenge in this project was how could we utilize as much as their existing infrastructure as possible to reduce the investment cost without interrupting with their ordinary operations. Another example, we have also been approached by another customer in Latin America. In addition to reduced investment costs, in this case they wanted a system which could provide flexibility. And due to the current low prices for ethane, they wanted the flexibility of both handling handy-sized ethane carriers for import from the US, as well as being able to import LNG in the future. So therefore we designed a system which is capable of handling both ethane and methane, as well as different kinds of vessels to give them flexibility in the value chain. We are also working on several projects in quite extremely shallow waters, which is actually often the case around the globe. For these projects, we look at how we may conduct cryogenic transfer for kilometers through either a subsea pipeline or alternatively to construct a simpler trestle structure for parts of the distance. We have also worked with port authorities looking at how we may enable LNG bunkering in ports. And for ship owners, it is important to perform the bunkering concurrent with cargo operations to reduce the time in port. Often bunkering from the seaside is the only option, since the safety zones for quayside bunkering often takes up a lot of the quay space. Ideally, you could use a LNG bunker vessel, which is a flexible and good solution for this. However, we have seen that the LNG bunker volume is in many cases too small to justify investment in an LNG bunker vessel. And when talking about cruise ferries or large cargo vessels, the volume is often too large for bunkering from trucks. So through our transfer system, we have developed an alternative solution for this. So just to summarize, the LNG market is growing rapidly, especially on the downstream side. However, the growth is being challenged by high infrastructure costs. There are challenging times for the maritime industry, which promotes the need for cost-efficient solutions. So what I want to say is that let's work together towards a sustainable and clean future for the maritime industry. So thank you so much.
Great, thank you, Morten, and thank you for the insight into LNG market expansion and the challenges, especially interesting around bottlenecks to infrastructure and how Connect LNG is innovating to remove those bottlenecks, and especially interesting to see those case studies. Once again, if you have any questions for Morten, please put them into our chat toolbox, and we will pose them to him within the Q&A session. For now, I'd like to move on to our final speaker, and that's Kronemeijer, CEO of GoodFuels. Over to you, Dirk.
Good afternoon from Amsterdam. This is Dirk, CEO indeed from GoodFuels. I would like to kick off ideally with a small video. If it doesn't work, I have a backup PowerPoint ready. So let's see if it works.
We think that sustainable marine biofuels should be part of the future fuel mix. It's not the only option, but it should be part of a set of options. The inspiration of starting with this project that we, as Boskalis, believe that by creating a biofuel for the shipping industry based on sustainable feedstock, we can start with a new market segment that wasn't there.
We can't make this market alone.
And this is why we are so glad with the great support we're getting from Boskalis and Wärtsilä. We need this launching customer, but we also need the port to provide the right incentives and to help us with finding the right clients, to help us in getting the supply chain in place. As Port of Rotterdam, we want to be a front runner in the development of the bio-based fuels. And why? Port of Rotterdam is home to a very large industrial cluster and already home to the largest renewable industry cluster in the world. Sufficient volumes of feedstocks that meet all the necessary sustainability criteria, but also are affordable, is a huge challenge.
As a Ministry of Infrastructure and Environment, we are also a target-setting body, so we set the standards.
Well, we recently bunkered Willem van Oranje with the first load of biofuel, and that was reasonably successful.
It's still a pilot because we have to prove that it's workable and scalable and sustainable. We started with a B30 blend on board of this vessel. It gives us the hope and the trust that we can scale it up to B50 in the near future.
We have a lot of experience of running on biofuel, also much more challenging biofuels. So our very short expectation is simply to prove that these fuels work.
Innovation is the key issue, and that's what has driven our company at the moment. We contribute to a more sustainable environment, and that's one of our goals in the future, to establish projects in a more environmentally friendly way.
So what are we testing at this moment? We are testing 3 different biofuels of 3 different grades. One is, shall we say, more easy, more light fuel oil-like, and the 2 other ones are becoming slightly more challenging.
This project is not only for Boskalis, it's a project for the maritime industry in a global way. And at the end, if we can use a waste product and we can turn it into a new source of energy, I think that will be the success of the biotropic fuel.
This second generation HVO, yeah, it's scary, but according to the contracts, it only has advantages. I can name all the advantages, but you can do your homework and read it. But they claim a 50 to 90% CO2 reduction. Why now? Yeah, because the possibilities are there and the technology is available, so why not?
We need more sustainable energy, then that is something that can become a customer demand.
At GoodFuels, we recognize it's very hard to make real sustainable biofuels. As a solution, we have implemented an independent sustainability committee to make sure we're always working according to the latest and most strict sustainability criteria. The sustainability committee has to approve of the sustainability aspects of all the products we sell or develop.
Good Energy has a wonderful corporate goal to help the marine shipping industry to convert from using some of the most polluting transportation fuels to sustainable marine biofuel.
We can only succeed when it's truly sustainable. And we would like to have a global standard for that, such as the Roundtable of Sustainable Materials Standard. But that's not presently yet there. And that's why it's important that this initiative has installed a sustainability board to look critically at all these new processes and products and technologies to see whether really all aspects of sustainability are taken on board.
We're happy to work together with GoodFuels and other partners to make solutions become a reality.
This topic is getting more and more important for our clients, not only shipping clients, but also the clients of the shipping clients. Currently, biofuel technology is getting so sophisticated that it can make high quality fuels from very low value waste streams.
We absolutely need a transition from fossil to more alternative fuels in all the transport modes if we are to reach the 60% emission reduction targets for the long run. In order to be able to do so, we need more innovations in the market to make those innovative leaps cost effective.
And this is of course where we have a tremendous economic opportunity. A lot of the feedstock that's currently being burned today as so-called green electricity, we can actually upgrade to marine biofuel.
It needs to transport itself in order to make a shift in that market itself with the partners from that market. And we must also realize that in that process of doing it, it also has to present a business case somewhere down the line.
It's a whole chain of suppliers, of mechanism which have to be made available in order to be able to use it worldwide. So it's not only the technique itself, but it's also the logistics behind it.
It's clear to all of us that the world needs more energy efficient and sustainable solution. And at sea, the growth has been roughly 3% per annum, and we think that will continue also in the future. We all need to take care of the health of our planet.
In the handling of cargo, the percentage of biofuels will grow. That can be scaled up enormously, and if it's, let's say, up to 10% of the existing fuel handlings we do right now, then you're speaking about 4 million tons for the Port of Amsterdam.
In 2030, our bets are that 5% of the total marine fuel consumption is going to be marine biofuel.
Bio-based economy provides a tremendous opportunity for the Netherlands in terms of greenification of our mostly fossil-based economy. Aviation as well as marine are sectors that cannot do without liquid biofuels.
Our vision is to go to full-scale biorefineries to produce lignin and sugars. We think marine biofuels made from lignin are complementary to the chemicals made for the chemical industry.
Steeper Energy sees the heavy transport sector, including marine propulsion, as the best opportunity for advanced biofuels. Our proven hydrofaction process converts biomass to renewable fuel oil. With minimal upgrading, hydrofaction oil can be used directly as marine distillate. We are working with global leaders like GoodNRG to produce large volumes of renewable marine fuel.
Of course, they want to have economic success, but the real thing is to move to a slightly better, more cleaner world, and this is where we are going for.
Okay, so I think this is this film gives a pretty good overview of what we're trying to achieve with GoodFuels. Quick history of the company. Originally, we are coming from the aviation space, where biofuels. Don't know what's happening.
We have to build cities. We need them.
Sorry,
but
guys.
we have to make them in a different way. We need
Apologize. Yeah, so originally coming from the aviation space, where we are still today the proud global market leader in sustainable jet fuel, but now moving into shipping, and from a strong belief that yeah, also CO2 is going to play a more prominent role in the shipping industry. Biofuels have so far not played a major role there, but we think that it's going to change, and that alongside also LNG, biofuel will play. It's going to play a major role in helping to make the whole industry more sustainable. What we have done in order to make this sort of industry is, yeah, just like we've done on the jet side, we have a supply chain whereby we very much focus, first of all, of the feedstocks. The feedstocks determine the price, but also the sustainability. And via our refining partners, we make our own blends in various qualities and resources. And via logistics partners, we ship it to our end client. We are active in those geographies in the world where there is strongest urge to use this type of fuels, and that's very similar to the hotspots on the jet fuel side, which is West Coast US, Europe, particularly Western Europe, Nordics, and Australia. But you also see that, for instance, next week we are in Singapore. It's getting more and more attention for this type of stuff. But obviously, at this moment in time, we need also the local incentives that are available in these geographies to compete head-on with fossil fuel. Sustainability, Christos already mentioned it. It's of crucial importance. You know, it's no point making, in our view, a biofuel that is supposed to fight climate change if it's destroying the rainforest at the same time or is competing with food. And this is why we have set up a very strict sustainability procedure, making sure all our fuels are meeting the highest standards. We are both a member of ICC as RSB, RSB being a standard set up by the NGOs, which is very, very strict on sustainability. But next to that, we have our own so-called sustainability board, whereby we have a number of NGOs basically advising on all the fuels that we sell in order to make sure that all the fuels that we sell are truly sustainable. So what we actually provide then to the clients is basically we try every year to come up with the best fuels available that are, as Christos said, are technology-wise compliant. So the OEMs ensure that the guarantees will still be valid, that they are sustainable, but of course also very important is the affordability. And affordability, I mean, this is basically where we specialize in. I mean, we try to operate in these geographies. You also saw from the film that we have a strong partnership with certain ports providing incentives, and in this way we make it affordable. You see that, for instance, also dredging companies use our fuels and they have a business case because they win a government tender. So we are very creative at this moment in time to make our product compete with fossil fuel. Longer term, however, we try to develop fuels that can compete outright with the fossil world. That's particularly with the low oil price a tough challenge, but yeah, we also see that also the biofuel technology world is going very, very fast, and now we can already make, particularly for the marine segment, very low quality, and I mean that with the fuel with respect for the fuels. I mean that these are all fuels meeting HFO standards, but are at the same time sustainable and affordable. So zooming into the marine, what is the rationale? As you all know, regulations for shipping companies to switch to alternative fuels, but in particular geographies, also CO2 is becoming a more important driver next to SOx and NOx. If you look at our product, then you see that biofuel inherently has no SOx, so that's a huge advantage. But the strongest point definitely is, of course, the greenhouse gas reduction, around 80% versus fossil fuel. But where LNG basically is stronger is on the NOx side. I mean, with our best fuel, we achieve a NOx reduction of around 10% at the moment, without any alterations to the engine. Here, we are also working hard in extending our product range and making sure that yeah, we improve all our products across the ratios. But we also want to, it's also a philosophy, and we don't see ourselves competing against LNG. LNG will play a prominent role in this industry, but there will be certain ships, there will be certain segments that will not go to LNG, but will prefer to stick with a drop-in fuel as we deliver today. But of course, that needs to be sustainable, and that's exactly the segment we're going for. Short term, we're very much focused on the marine gas oil market, obviously due to the higher incentives, but also the product itself is a lot easier for us to cope with. But longer term, we're also working together with partners such as Wärtsilä on a first drop-in bio heavy fuel oil. But to manage expectations, we see that at least we're going to do some first tests this year, but a commercial volume available will take us at least 3 years to have in the market. So until that time, we focused completely on marine gas oil. Then the customers, what you see is that together with Boskalis and Wärtsilä, we have set up a longer-term program to test various biofuels into the system. If we can demonstrate it works well, then we also try to get them certified at CMAC and IMO level. But so far we have already a couple of fuels in the market that are commercially available, that have met all the standards as put forward by a number of leading OEMs. And this is where we are also getting more clients. You saw in the film, for instance, coast guards, ferry companies, dredging, particularly everything short sea at the moment is our prime target. And this is where we want to grow the marine fuel, biofuel footprint. So with this, yeah, I wanted to quickly introduce our company to you and show you what's happening on the marine biofuel side. And of course, very much looking forward to any feedback or questions you may have.
Thank you, Dirk. That was extremely interesting, and it's such a great initiative and program for the industry, and it was very interesting to hear what you've brought from the aviation biofuel side and how that can be applied into the maritime industry. For now, I recognise that we have 1 minute until 3 o'clock, so I would ask that people stay tuned in. We'll do a quick 5 to 10 minutes question and answer session. The questions have been flooding in, and so in the essence of good timekeeping, I've picked a question for each panelist, and then any other questions we can put to the panelists offline. So the first question that we've had was for Christos DMVGL, and that one was around LNG. The question being, which ship types are most likely to pay a premium for investment in LNG as a fuel, especially when considering retrofitting LNG fuel storage onto existing vessels? And they give the example of, would it cost more, for example, to install LNG fueling infrastructure onto a bulk carrier versus an oil tanker?
I think it's going to be mostly ships operating most of the time in emission control areas. Probably in the North American emission control area, because from next year for new buildings we'll have the NOx standards as well, and LNG can be used to address that. The cost of retrofitting is going to be different depending on ship type, and that will have to do with many things, but one major consideration is where you have space for fuel tanks. So for some vessels you can have them on deck, in other vessels you can't do that because you don't have space available on deck. But I would think that we'll see, we already see quite a few ferries using LNG as a fuel. I think we'll see more, and we'll see more and more larger vessels. It's very hard to say now which types will be more relevant, but I think what we're going to see is that we're going to see more and more larger vessels using the fuel. I hope that that helps a little bit. Also, I would like to add that in general, retrofitting is much more expensive than installing the equipment in the new building phase. And because there's a lot of uncertainty as to whether you would like to have LNG in the future, one concept that we have now is that we have this LNG ready service, where you can design a new vessel to be ready for installing LNG at a later stage at a reduced cost. So you can prepare all the space and everything you will need for installing, for example, an LNG tank, and that will make a retrofit much easier in the future. So you can build a vessel that is more flexible.
Great, thank you, Christos. And my second question is for Morten, Connect LNG. Have Connect LNG received many inquiries for the use of the platform Connect LNG as a method for ethane bunkering? And could the technology be adapted to other types of gas fuels?
Yes, we have been in discussions with some ports regarding bunkering, and the main reason is that a lot of the different ports are now, especially in Europe, required to be able to serve LNG as fuel in the port. But in a lot of the cases, you could do that with a truck filling, as we do mostly in Norway. But when talking about some larger volumes, especially larger carriers and ferries, it's challenging to be able to bunker a ferry in 1 hour by using trucks. But the volume is still a bit too small to justify investment in bunker vessel in many cases. So that has been the discussion around that. So we have developed a system for seaside bunkering. So there has been some requests on the bunkering side, but mainly for small-scale LNG transport, and especially for power generation in remote areas, for instance, Indonesia, Caribbean. So stuff like that. When it comes to other products, we have focused on LNG, but we have also developed a system for ethane. We have looked into LPG. In a sense, our transfer system is essentially a floating jetty able to transport any kind of different fluid, regardless of if it's cryogenic gas or oil. I hope that was an answer to the question.
Yes, perfect. Thank you, Morten. And then another question for Dirk, GoodFuels. Will there be any extra cost for ship owners looking to make the change to biofuels? So, for example, would diesel engines need to be adapted to biofuel use? And what would the modifications on board be?
Well, let me start with the latter question. In principle, all our fuels are so-called drop-in. That means you don't have to make any change to the engine. Guaranteed by the OEMs as compliant fuels. However, it's linked to the affordability part. So far, as said, it's not for nothing that we operate in countries like Netherlands, Norway, West Coast, US, Australia, because this is where you have local incentives available and local regulations available, making this affordable and compatible with fossil marine fuel. So we need the current biofuel regulations there in order to compete. What we're also looking at as sort of a second wave, and currently doing some tests with a ferry company, is to use a lower priced biofuel that does require alterations to the engine, be it very limited. Yeah, so we're also exploring ourselves a little bit on where the market is going to go. I mean, typically all our customers love the fact that they don't need to change anything to their infrastructure. However, yeah, if you have a to B type of ferry operations, for instance, that does require a much lower CO2 footprint, then yeah, a small alteration to the engine is potentially also something that could be up for discussion with the owner. as it does make even lower priced fuels available to him. So I hope that makes sense. Yeah.
Perfect, thank you. And I think just before we hit the 10 minutes past 3 p.m. GMT mark, I'll just pose one final question. And I guess this question will be for Morten. And it starts with a statement, so a big part of the promotion for using LNG as a marine fuel until recently was based in the eventuality of a lower price compared to HFO. Taking into consideration the current low prices for HFO and the wider global infrastructure and supply bottlenecks for LNG, is this argument still valid? And what are the recent projections around LNG fuel prices saying?
Well, I should be careful to say too much on that subject. That's more for traders. But what we have experienced in lately is a drive towards cost efficiency. A lot of the projects which were feasible for a year ago, it's more difficult now. Because the margins has dropped due to oil price. I would strongly believe that, especially in the mid-term, long-term, we will see a lot of vessels running on LNG. I think first and foremost, it will be like we see in ferries and vessels going from A to B in the same routes. But the drive has been lately, I think, a bit stronger on the power generation side compared to the fuel side when talking about LNG. But we need to remember that one of the biggest drivers here is the governments and the drive towards more cleaner fuels, which is very important to push this forward and regulations in place to be able to switch to cleaner energy. And the EU has done a lot in this regard, and will push forward despite the low oil price. Hope that was somewhat an answer.
Yeah, perfect. Thank you, Morten. Very insightful. I think for now, due to the timing, we'll have to wrap up this extremely interesting webinar. And I'd like to thank all of our speakers for taking the time out of their schedules to present to us today and share insight into their expertise. And thank you all for joining us. A listen again link with a recording of this webinar will be sent to all attendees in the next couple of days. And we look forward to joining us for the next Ship Efficiency webinar. In the meantime, please keep an eye on fathomshippingevents.com to see when our next webinars and indeed industry events are scheduled for. And a big thank you to everyone from Fathom Maritime Intelligence and myself. See you all soon.